Welcome back to Advanced Functions, MHF4U 1. This is Trigonometric Identities and Equations chapter. In this lesson number 5, we are going to learn how to solve a linear trigonometric equation. Number 1. So we're going to dive into the question right away using all the trigonometric equation and characteristics that we learned in the previous section. When the question says solve for x, so we're looking for an angle. So x is in between 0 and 2 pi. So tangent x is equal to negative square root 3, and this is the restricted domain. So first things first, what we're going to do is we are going to figure out what the angle x is. So x is equal to, I'm going to move tangent, so it becomes inverse, tangent inverse, negative square root 3. So once you punch that in your calculator, x is equal to, you're going to get, so if it's in degree, it will be 60 degrees, but we're working with radians, so it's going to give you pi over 3. So this is a exact angle that special triangles that we looked at, which is 30, 45, 60. So I'm going to draw a triangle here. So let's say this is pi over 3, pi over 6. So it's going to be 1 square root, so this is 3, 2 square root 3. So therefore, we understand that you can find an exact answer using the special triangle. Now, first things first, we understand that tangent is negative. So using cast rule, we need to figure out which quadrant would the tangent be negative, because the domain is from 0 all the way 1 revolution until 2 pi. So as you can see, tangent is going to be negative in quadrant 2, because only sine can be positive here, and quadrant 4. So we write quadrant 2 and quadrant 4. Now, to find this, we already have a related acute angle. The related acute is x over here, which is 60 degrees. That's my related acute. So to find the angle in quadrant 2, all we need to do is pi, right? Remember, if we're using related acute, the angle that we're referencing to, it's always the x-axis, which is 0, pi, or 2 pi. So it's going to be pi minus pi over 3, which will equal to, make the same denominator, you will get 2 pi over 3. So this will be one of the answer for x. And for quadrant 4, the formula is 2 pi minus theta. In this case, my theta is pi over 3, my related acute. So make a same denominator. It will be 6 minus pi, so it's going to be 5 pi over 3. So therefore, we have two solutions because it's only between 0 and 2 pi. So x is equal to 2 pi over 3. I can say x1, and x2 will be 5 pi over 3. And that will be my final answer. Question 2. So again, the restriction, the domain is the same. This time, we are given sine x is equal to negative 0.37 in radians. So it's not really exact, so it's a decimal. So I would recommend that you use a calculator. X is equal to sine inverse negative 0.37. And you're going to get x is equal to 0.38 in radians. So what does that mean? Well, using my cast rule, let's figure out where my sign is negative. So sign will be negative in quadrant 3 and negative in quadrant 4. So therefore, to find the angle, so we know x, this one, 0.38, it's an acute angle. Okay, so I could say related acute angle. So to find the angle in quadrant 3, it's always pi plus, because it's 180 degree, plus related acute, which is 0.38. So approximately, remember pi is 3.14. So you'll be doing 3.14 plus 0.38, which is about 3.52. And then quadrant 4, it's going to be, so to find this angle, we're going to do 2 pi minus my related acute. Here. So x is equal to 2 pi minus 0.38 is going to be 5.90. So 2 pi, you can do it as like 2 times 3.14 and then subtract this. Okay. Now, so therefore, we have two solutions. So x1 is 3.52. Now, if I really want to be exact, if, for example, if I did not have restriction between 0 and 2 pi, because remember that for sinusoidal, it happens in sinusoidal period in a cycle. So the period of sine is going to be 2 pi. So we are going to use, let's say, the letter K. It means it's like any integer. Okay, so K is that the integer, and Z means that it's a repeating. K can be any real number. So therefore 3.52 plus 2 pi K, and K could be any integer. Because this negative 0.37 is going to happen again after 1 cycle, 2 cycle, and 3 cycle, and so on. So you will be writing this component if there is no restricted domain. Okay? But if there is a restricted domain, then you'll be writing just 5.90 as your final answer. But then I could say 2 pi k, the k being any real integer, which is represented with z, any integer. Question 3. So again, same thing, solve for x. So I do give you a restriction. So it's cosine x is square root 2 over 2. So using your calculator, I'm going to do x is equal to cosine inverse square root 2 over 2, and you will get 45 degrees angle, which is pi over 4. So let's see. Using cast rule, where is cosine that will give me a positive ratio? It's going to be quadrant 4 and quadrant 1. So therefore, we already found the answer for quadrant 1, which is my related acute. X is equal to pi over 4. Now to find the answer in quadrant 4, we're going to do 2 pi minus my related acute, which is pi over 4. And that will give me 7 pi over 4, because the same denominator, 4 times 2 is 8, 8 minus pi is 7. Okay, so therefore, my final answer is that x1 could be pi over 4, and x2 is 7 pi over 4. Again, if I did not give you a domain of a restriction, then there's going to be a lot of answer. Okay, so if I say there's no domain, then you could say x1 is equal to pi over 4 plus cosine, as same as similar to sine, the cycle happens every 2 pi. So it's 2 pi k. K can be any integer. And same thing, 7 pi over 4 plus 2 pi. It will happen again every 2 pi. And k can be any integer if I did not give you domain. Question 4. So solve for x. Again, it's the same domain. Now this time you see an expression where sine x plus 2 cos x sine x equals 0. Now to solve for x, you want to isolate it. So if you have an expression like this, try to factor and see if you can factor as much as you can. So yes, there is a common factor of sine. So sine x, 1 plus 2 cosine equals 0. And after we factor, we can let each multiple equal to 0. So I could say sine x is 0. And for this multiple, it's going to be 1 plus 2 cos x is equal to 0. Now, whenever you see 0, pi, or 2 pi, the angle that is on the 0, that means you have to think of a unit circle. So in this case, the point is xy. And I hope you remember x represents the cosine value and the y represents the sine value. So we're looking for when y is 0. So y is 0 when it's over here and over here. So here in this case, negative 1, 0 and 1, 0. That's when my y value, which is my sine x, is 0. So therefore, when it's on this point, my x is going to be 0 degrees. And when it's over here, my x is going to be 90 degrees, which is pi. Okay, so we have two answers for this one. Now, what about this one? So let's isolate x. So I'm going to move 1 to the other side. So it's going to be 2 cos x is equal to negative 1. Let's divide both sides by 2. So it cancels out. And then cosine x is equal to negative 1 over 2. So I'm going to move cosine, do an inverse. X is equal to cosine inverse negative 1 over 2. And when you punch it in your calculator, you're going to get pi over 3, which is 60 degrees. Now, after you find the related acute, now we need to figure out the cast. So which quadrant with my cosine is going to be negative here? So it will be negative in quadrant 2 and in quadrant 3. So for quadrant 2, x is equal to, we got to do pi minus related acute, which is pi over 3. And that will give me 2 pi over 3. Now for quadrant 3, it's going to be pi plus my related acute, which is pi over 3. So it's going to be 4 pi over 3. So therefore, what are the answers for x in this equation? We have 4 possibilities. x could be pi, 0, or 2 pi over 3, or 4 pi over 3. There are 4 possibilities. Question 5, same thing. Now this time we're given a fraction of an angle. So we have secant x over 2 is equal to 2 square root 3 over 3. Okay, so first thing I want to do is, let's see, what I'm going to do is I'm going to make a secant into primary trig ratio. So secant is equal to 1 over cosine. So what I can do is I could say cosine x over 2. So I'm going to flip my answer. So it's going to be 2 over square root 3. Do you see that? So technically, I could be rewriting this as 1 over cosine x over 2 equals 2 square root 3 over 3. But instead, what you could do is you could flip these two. So if I flip these two, then you also got to do it on the left side and to the right side. So that's why you will get this. And then I'm going to do an inverse. So x over 2 is equal to cosine inverse 2 square root 3. And then x over 2, you're going to get 30 degrees, or pi over 6. And now what we can do, it's simple. So we're gonna isolate for x. So what you can do is you could bring 2 to the other side. X is equal to 2 pi over 6, which is pi over 3. Therefore, now, so after we found my related acute, let's figure out the cast rule. So which quadrant with my cosine going to give me a positive ratio? So it's going to be in quadrant 1, and cosine is going to be positive in quadrant 4. So in quadrant 1, we already know my related acute is pi over 3. And in quadrant 4, we're going to do 2 pi minus my related acute, which will give me same denominator. It's going to be 6 pi minus pi over 3. So therefore, it's going to be 5 pi over 3. And that will give you your final answer. Okay, last question. So we're given 2 sine x cos x equals 0. So let's see. Now there's not much what you can do to sine and cosine because it's already primary trig ratio. So see if you could replace this using any identities that we studied, or the compound or double angle formula. So you will notice that this could be rewritten as sine 2x, the double angle, is equal to 0. So what that means is that sine, where is sine 0? So we studied in the previous question, sine, where it's 0, it's going to be 0 degrees or pi. Okay? So therefore, there's two options. Option 1 is that 2x is equal to 0. Okay, that's 1. And for pi, it's going to be 2x is equal to pi. So therefore, I'm going to move 2 to the other side. So x is equal to pi over 2, and then x is equal to 0. So there are two possibilities. The angle could be 0 or pi over 2.